I'm Thierry Brousse. I'm professor at Nantes Université. I'm dealing with materials for energy storage, especially supercapacitors. As we probably are all aware, the energy density is not meeting the purpose that people are waiting for, and that's one of the most important challenge. I guess that improving with different type of materials can indeed be a good idea, but at the same time you've got to keep a reasonable power density and you've got to keep a good cycling efficiency. I guess that the most important challenge is where should we put the point for this trade-off, and not so many people can answer this question. You can change materials to, let's say, increase your capacity. You can widen your potential window and then you widen the cell voltage. But will you affect something else? There is a combination of components. If you change one component inside the cell, then you are affecting the whole cell itself. I mean, that's not only a problem of changing one material with another. You must have the scientific concept that is proving that you are going into the right direction. Then you can go a little bit further, and this is done at the laboratory scale, but there are some technological centers like CIC energiGUNE that can implement this to, let's say, some scaling up. And then after that, you will be able to provide this to a real-life company. Lithium-ion capacitors were bridging the gap somehow between these EDLCs that are also very interesting in terms of properties, but with much higher energy density, which is going toward the direction of increasing the energy density just to get close to lead-acid batteries. Indeed, we all know that the lithium resources is currently getting scarce, especially if we are increasing the number of lithium-ion batteries for the cars. So, which means that probably metal-ion capacitors, the future should be with sodium-ion capacitors. In this case, you are no longer limited by the resource in sodium, and it's much more efficient to extract without going into big pollution of the soil. So we know that lithium-ion capacitors have been some kind of technological step, and my believing is that we will go in the future toward more reasonable devices. Sodium-ion capacitor seems to be the good one. I think that we've got some kind of a mimic of the lithium-ion capacitors. We've got the right materials, but to my sense, the most difficult to achieve is the pre-sodiation step. In this case, it will be more difficult to use a metallic sodium foil, just because sodium metal is quite difficult to achieve and handle. So from a safety point of view, from an economical point of view, probably the right solution in this case will be to use some kind of sacrificial material that will provide sodium only once to the hard carbon negative electrode. And if we succeed into solving this problem, probably this will help to go further into the technological achievement of such device.